these things are the battery. The battery technology didn't change. So that's why all these things are going to go. And new opportunities are rising from the knowledge system, more than more opportunities. That people are trying to integrate already. There's a company Analog Devices you might have heard. They have integrated a lot of MEMS along with electronics in one few set of masks, one chip. The energy, environment, and biomedical industries will grow remarkably. So now you got to think about the ideas. Brainstorm it, figure it out what you can be millionaire, believe it or not. That's what you got to think. This is not two things actually you need. One thing is your idea. You can get different ideas and apply it to new approaches. So for example, for IoT applications, see what we can do. There are many things are floating around. Bringing them together and making a device can be very rewarding. So this new, so the idea is you can be the game, you can be the leader now. It's not necessarily you have to wait. Everything has to be developed in America or Japan to come up with this device. Now anybody can come up with this thing because the know-how is available. So that's what actually you got to think. How I can apply this and how I can look at some of the requirements. How I can have something my home to change this. Okay, do I need that first? Once I need that, I want to have solve the problem. Once I want to have to solve the problem, what is the knowledge I need to know in terms of these things? And building that thing in a large one, then shrinking it to the small one. Then it will be invisible, but it will be very rewarding. That's what actually the message in this. So the idea is for this talk. Now, what I said, this is actually a summary thing. Now we'll go to the how requirement. What is the power requirement? How it is coming through the devices. An introduction of high K. Why high K came. What are the physics behind that sort of things. Then we'll go to the, if we have high K, then what are the things that we're going to look at and what are the things that people looked at. That actually like a class. Then we will go to the next level. What is the current state of the technology in high capable are working? And then what are the issues we got to look at? And like breakdown characteristics, reliability issues. I will talk about the reliability issues. And then what happens to the the circuit application, the device applications to different devices. Let's say if I go to optoelectronic devices, what do you do? How to solve the problems there? And then how different parameters affecting this. For example, hydrogen, role of hydrogen in these structures. Like if you anneal hydrogen, will it always work? Can you passivate different things so that we'll have solved the problems and make a better device? So that also will discuss. So this is all I will change depending on your background and interest. So I do not know. There is no point talking one thing when half of the people are not interested. But this is general knowledge type of thing I would like to discuss. Now, any questions, any suggestions? So that sort of things will. This is overall idea. You may have some ideas now already, but this gives you some overall idea. That's what the direction of the technology is. Any questions now?
I just want to ask something.
Sure, sure.
What are the nano sensors available so far for IoT?
Pardon?
What are the nano sensors available so far in IoT market?
IoT market?
Yeah.
There is a lot of healthcare. With healthcare related, there is some money involved. Like money in the sense people are willing to buy. So the health monitoring devices, many of them are there. For example, the pad, there are devices to test A1C things. You might have heard the ISC Bangalore group. Forget about in the US. ISC Bangalore, the product that came out A1C test, they are now marketing in the US. So mostly healthcare and many of them. And some of the industrial applications there, especially environmental sensors in the industries, they put a lot of sensors, very tiny sensors, and well networked, and outside also in the fields. but they are not wireless sensors. Even though they are they are not mobile sensors. That's fixed. So that actually is already in the production, like people can buy. But for household applications, many of the IoT devices are already there in appliances, built into the appliances. Of course, it increases the cost of the appliances. But there is no as such. You can buy an IoT product. But some of the applications are there, but the networking of all the devices are still waiting many years. Any other questions? No? Any other suggestions? This is just the idea. What do you want to hear? I got something. Yes.
So if like we are from core electronics, and if you want to work on Eaton, for example, I want to work on Eaton.
Mhm.
So what should be the approach? Now my knowledge is more focused towards electronics. So what should be my strategy to learn about? First, I have to gain knowledge
The
about
sensors and all. Okay. The best part is not a single individual can solve all the problems. Main thing is team up. Let's say the biggest problem is electrical engineers talking to chemists, chemical engineering, mechanical engineering. Normally they are tough. So the idea is if we can collaborate. See, somebody is very good in biology, and you cannot learn everything about biology and develop a sensor because you are good in electronics. So the idea is to find out collaboration. There is a lot of collaborations in UPenn, even in Cornell University. You can have biology students, electrical engineers, physics students, all in. You cannot have two electrical engineering PhD students sitting next to each other. That's not acceptable. So the idea is to talk to each other. Like, okay, I have this idea. This is the way things work. Then you can say, okay, somebody can explain. Can we do that? Can you work together to develop a sensor? Let's say somebody is very good in biology and someone is very good in electronics. How to bring them together? That's what actually is communication. Talking to different discipline, interdisciplinary problem. So you cannot expect that I will solve everything. But the moment you have the idea, then talk to somebody who is knowledgeable in the other side that you do not have the idea. That way you can bring and make it, think about a product. Any other questions? No? Okay, so we'll meet later then. Okay.